All right, this is part 2. We're looking at section 2.1. We're organizing qualitative data. And now we've got a question here. And we're talking about a random sample of 2,163 adults ages 18 and over. Okay, so our population is adults ages 18 and over. They were asked, when you see an ad emphasizing that a product is made in America, are you more likely to buy, less likely to buy, neither, more nor less likely to buy? And the results of those surveys are down below. So you can see the blue is more likely, the green is less likely, and the orange is neither. And here are our questions. We want to know what proportion of 18 to 34-year-old respondents are more likely to buy when made in America. What proportion of 35 to 44-year-old respondents are more likely to buy when made in America? So on part A, okay, 18 to 34-year-olds, so that's the first category that we have here. And which part of them are more likely? So that's in the blue, and that's right here. I'll call it 0.42 as the relative frequency. When you don't have the exact numbers, sometimes you do have to guess, but we'll say 0.42, 0.43-ish, somewhere in there. I'll go with 0.42. What portion of 35 to 44-year-old respondents were more likely? So 35 to 44. Okay, theirs is right here, and it's just a little bit above 0.60. So I'll call that 0.61. Okay, so those would be the proportions of the 18 to 34-year-olds and then the 35 to 44-year-olds who are more likely to purchase when it says made in America, based off of the data that we have in the bar graph. And again, this information is referring to relative frequencies. Okay, part B asks, which age group has the greatest proportion who are more likely to buy when made in America? Okay, so we're looking for more likely, which is in blue, and the highest peak here is right there, and that would be our 55 plus group, according to this data. Okay, C says which age group has the majority of respondents who are less likely. So less likely is the green. So the highest green we see here is the 18 to 34-year-olds, so it would be that age group. So those that are 18 to 34 years old. And part D, what is the apparent association between age and likelihood to buy in America? So if you look at the trend of blue, then as age increases, there is a greater tendency to buy, made in America. Because again, if you're looking at that blue from left to right, you see an upward trend of the blue, which means as you get older, you're more likely to buy, and you see a downward trend in the green, which would correlate to that. So again, an increase in age is showing an increase in tendency or likelihood to buy. Okay, this information right here is in your textbook. It's going to talk about the program called Statcrunch and how you can create a relative frequency distribution or a frequency distribution using Statcrunch. I'm going to go through and show it to you But if you wanted to pause the screen and take any notes here, okay, that's the relative and the frequency and the relative frequency explanation. And then down here are the bar graphs and the pie charts. Again, I'm going to go through this for you, but that is also found in your textbook, your textbook that you can find. So we're going to look at Walt Disney stock. So the table below shows the movement of Walt Disney stock for 30 randomly selected trading days. So up means that the stock price increased, down means the stock price decreased, and no change obviously means that it closed at the same price that it closed the previous day. So this data comes from Yahoo Finance, and you can see we've got down, 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 no change, up, up, down, down, up, and so on and so forth. And we want to construct a frequency distribution, a relative frequency distribution, a bar graph, relative frequency bar graph, and a pie chart. So lots of stuff going on here that we need to put together. And we are going to use Statcrunch, which is a program that is extremely powerful and you're going to use a lot in this class to create these things. So first, to get into Statcrunch, okay, on your home page, you're just going to be looking under student links and you'll click on Statcrunch. Okay, and then it'll take you there and you want to go to the Statcrunch website, and eventually you're going to get logged in and it'll look like this. So what I've done is I've gone in and I've put in our table of data. So I've typed in all of this data right here. Sometimes, most of the time in your class, you're going to be able to import that data. When you click on the data, there's going to be like a little double square, so like a little square and then another little square, and you'll click on that and it'll say open in Statcrunch, which is very nice and handy for you. Okay, so I've got this, and the first thing we want to do is create a frequency distribution. Okay, here's how you're going to create a frequency distribution in Statcrunch once you have your data. Okay, so first I'm going to go to Stat, and I'm going to come down to Tables, and you can see here's a frequency table. Now it wants me to select the column. My column is in var1. I haven't renamed it anything, so I'm going to click var1, and I want a frequency table. And I will hit Compute, and you can see here is my frequency table for all of that data. So this would be the frequency table. Okay, if I click on Options, it's going to allow me to edit, and I could change that over to relative frequency and hit Compute, and now you can see here's my relative frequency. Or, I'm going to click Options, Edit, I could highlight both of these and compute, and it will give me the frequency and the relative frequency in one shot. So here's my down, no change, and up. Okay, so that's how we're going to calculate or put together these frequency and relative frequency tables. Okay, the next thing that it asks us to do is a bar graph. So for the bar graph, I'm going to go to Graph, and then Bar Graph. This time I'm going to click With Data because I have all of the data. I don't have a summary. So the frequency table would be more of a summary. In this case, I also have the hard data in that first column, variable 1. And the type is I want a frequency. And I'll hit Compute, and you can see here is the frequency distribution. If you hover over it, you can see the actual frequency in there. Or I'm going to go Options, Edit. It'll bring this window back up, and I'll put values above the bar. I'll click on that, Compute, and it will give me the numbers. So 15, 2, and 13. Okay, so there's that. Then I could hit Options and Edit, or again, just as a reminder, Graph, Bar Plot with Data, variable 1. Now I want the relative frequency, and I want to put the values above the bar. Compute, and there's my relative frequency. Notice that these numbers all match up with this over here. Okay, and then lastly, we want a pie chart. So I'm going to graph a pie chart, again with data, selecting variable 1, and everything else is outlined for you by default. And you can see here's down is exactly half, and then no change, and then up. And that gives you your relative frequencies on the side here as well. Okay, so that's Statcrunch. Again, super powerful tool for you to be able to use. Okay. Let's see, we're going to jump back over to our assignment here. So we just did all of those. Okay, again, here are those that I just took a screenshot for us. Okay, now this one right here is a previous question that we looked at. We constructed a relative frequency distribution of that up above. Okay, so that was one of the first things that we did. So that was done earlier in the lesson. And again, if you need that, I have imported it here. So here is the frequency distribution, and you can go ahead and get your relative frequencies. But we did that earlier, so I'm not going to take time to fill in the relative frequencies. Just remember that was up above in the lesson, so it should already be in your notes. So A is done. Part B, what percentage of respondents answered always? Okay, so you would just look at the relative frequency there. So that was 3,093 out of the 4,077, which was 0.648, or it wants a percentage of 64.8%. Okay, so that percentage is the relative frequency. Part C is, make this a little bit bigger here for you. Part C, what percentage answered never or rarely? So what you're going to do is you'd add those two frequencies together. So that'd be 118 out of 477 plus 24 or 249 out of 4077. So one or the other, you're just going to add the two relative frequencies together. Okay, when I add those two together, okay, from above, this was approximately 0.025 plus 0.052, which is about 0.077 or 7.7%. Okay. And then, let's see here, part D, it wants us to construct a frequency bar graph. So I'm going to jump back over here to Statcrunch. I'm going to go to graph. I'll go bar plot. This time I'm going to go with summary because I have a summary that I don't have the data listed out. I just have a summary. I have a frequency distribution. So the categories are in the response and the counts are in the frequency. So that's how I'm going to do that. And it wants a frequency, so I'm going to be frequency and I'll put the values above and compute. Try to get this a little bit bigger. Okay, and there you can see here is my frequency distribution. Okay. Then the next question in there was relative frequency, so you'll hit options, edit, and just change the type from frequency to relative frequency and compute. Again, I'm going to spread this out. Okay, and here are these relative frequencies for you. And then we want a pie chart. So again, I'm going with summary. Same thing. The categories are in the response column. Counts are by frequency. And you can see here is that pie chart. Okay. So I'm running up against the clock here. But the last one says, suppose that a representative from the Center of Disease Control says that 2.5% of the college students in the survey responded that they never wear a seatbelt. Is this a descriptive or an inferential? So this one is going to be a descriptive. So this is part H. So it will be descriptive statistic. And that is because it's a summary of the data collected. We're not making any inferences based off of or towards the population. So that's why we would call it a descriptive statistic, the 2.5%, instead of an inferential statistic. Because the inferential, we take the the descriptive, and then we make a prediction for the population. So hopefully that helps out.